All right, so I got the balancing up there for you guys. It's 1, 2, 2, 1. And then hopefully you guys were able to identify that your starting chemical is 15 grams of CH4, and then you are looking for grams of CO2. So you need to find the molar mass of CH4 and CO2. So if you look at your periodic table, which I'm not going to pull up, but make sure you guys have it in front of you. Carbon is 12.01. Hydrogen is 1.01, and there's 4 of them. So for CH4, you should get 16.05 grams in 1 mole. Okay, so we're just adding the carbons and the hydrogens together. God bless you. And then for CO2, same process, carbon and 2 oxygens, that should give you 44.01 grams equals 1 mole. Okay, so that's the first 2 things you want to do when you do these stoichiometry problems. First is balance, then find the molar mass of the important chemicals. Any questions about those first 2 steps? Hopefully that part's not too bad. And then we're just going to be plugging it into these fractions. Okay, so we're going to take our starting number from the problem, which is 15 grams of CH4, and we're going to write down 15 grams of CH4. All right, now if you guys remember, this first fraction is all about our starting chemical, so we're going to label it as CH4. And then we are going to get the numbers from the molar mass of the starting chemical, which is CH4. So we're going to use this right here and plug it into this fraction. All right, if you guys notice, the moles is on top of the fraction, and the number next to moles is 1. So we're going to put 1 next to moles. The number next to G is 16.05, so that's why we put 16.05 on the bottom. And again, this is the reason why it's important to label your numbers. It's so that you can put them on the correct position on your fractions. All right, for the second fraction, the bottom is going to be about your starting chemical, and the top is going to be about your ending chemicals. Just make sure you guys label that. And again, I know it's annoying to label all of your numbers and the units of measurement, but again, it'll help you guys out in the long run. I'm noticing a lot of people on the assignments flipping their fractions because they didn't label it. So just keep that in mind. Make sure you guys label. The bottom of the second fraction is your starting, and the top is your ending. All right, and the numbers for this one are going to come from your balanced equation. So we're going to look at the equation that we've balanced and then plug in our numbers from there. Take a look at CH4. There is a 1 in front of it, so we put a 1 on the bottom. And then CO2 has a 1, so we put a 1 on the top. All right, last fraction is going to be about your ending chemical, so CO2, and we're going to get the numbers from the molar mass of CO2. And then for this one, if you guys notice, moles is on the bottom, so we put the 1 mole on the bottom, and then 44.01 on the top. Okay, so if you got that set up, great job. Should be pretty easy. Stoic is going to be pretty much this. We're just going to be doing this pretty much until the end of the unit. Your lab that will be starting next class will be pretty much a lot of stoichiometry. You're going to be doing it multiple times. All right, so let's plug it into our calculators. Again, the numbers on the top, you're going to multiply, and everything on the bottom, you're going to divide. So we're going to go left to right. So the first number on the left is 15, and then 16.05 is on the bottom. So divided by 16.05 times 44.01. And so you'll get a final answer about 41.13. If you got that, great job. And then make sure you label your numbers grams of CO2. All right, so let's talk about the first of the 3 things that we're going to learn today, the TY. Now, TY stands for something called theoretical yield, okay? So write that down on your notes, theoretical yield. I always abbreviate it as TY, so you guys can do that as well. Okay, but TY stands for something called theoretical yield. All right, and it's pretty much what the name sounds like. It's your yield, so how much of a chemical you can make in theory, okay? So whatever number you get after you do your stoichiometry, that number is always going to be your theoretical yield, okay? So you guys can just label the number that we got for our problem as your theoretical yield. The theoretical yield is how much of a chemical you can make in theory, and so it's pretty much the number that we get from our calculation, so from our stoichiometry. So whatever your answer for your stoichiometry problem is, that is your theoretical yield, your TY. All right, pretty simple. Any questions on TY? Yeah, it's just the number that you get from your stoichiometry. So when you do your assignment today, if it asks you to find your theoretical yield, it's just asking you what's the answer to your stoichiometry problem. It's pretty much what you've already been finding for the past couple days. All right, let's move on to the next one. The next one is AY, and AY stands for actual yield. So you're going to write that down, actual yield. That's AY. Okay, and actual yield is, again, what the name sounds like. It's your yield. It's how much of a chemical you're going to make actually. So this is the number that you are going to get in your lab. Okay, so when we start our lab next class, you're going to be actually making chemicals, and then you're going to weigh it out on a scale, and whatever the weight is, that's going to be your actual yield. Okay. So today, we're not going to be doing any experiments or anything like that, but it's going to tell you in the problem what the actual yield is or how much you made in a lab. Whatever amount of a chemical you make in a lab, that's your actual yield. Okay. So theoretical is what you get in your stoichiometry. Actual is what you make in your labs. All right, now the reason why we need to differentiate between the two is because when we do actual chemical experiments and reactions, they don't actually produce the amount you're trying to make. Okay, chemical reactions are not 100% efficient. A lot of times you'll notice this as we do more labs, but things get stuck to your glassware. You might spill a little. Sometimes the chemicals just don't react all the way. And so there's going to be a difference between your actual yield and theoretical yield. And then the key thing that I want you guys to write down is that your actual yield will always be smaller than your theoretical yield. Okay? Your actual yield will always be smaller than your theoretical yield. It is impossible to make more than what your stoichiometry told you. The stoichiometry is like in a perfect world with perfect conditions where everything works out, but in reality, it's not going to happen like that. Okay, so your actual yield will always be smaller than your theoretical yield. So when you do your assignments today, this is a good way to check if you got the correct answer for your stoic. If it's bigger, or sorry, if your actual yield is bigger than your theoretical, something's wrong. So you'd have to recalculate. And there's a reason why. It's because, or so when you do your lab, if your actual yield ends up being bigger than your theoretical, that means there's something wrong with your product. Usually it's because there's other stuff mixed up with it. There's water inside of your product, or there's other contaminants like that. But we'll get to that later. The lab that we're doing next time, it's very difficult to get an actual yield bigger than your theoretical. So just keep that in mind though. But in future labs, when we do work with more liquid chemicals, the water weight is a big reason why people's actual yield is bigger than their theoretical. Okay. All right, so that's two of the three. The last one is called your percent yield, and I'm going to teach you guys how to do that in a second. Now, you guys don't need to copy down this yellow highlighted part. This is what we did in our previous warm-up problem. Okay. So let's label our number. So we already labeled our answer, the answer to the problem, as our theoretical yield. Okay. Now, in your assignment problems today, you're going to get problems like this where there's a part B, and it's going to say, if you do this in the lab, you make 40 grams of product. Okay, this is going to be your actual yield. So your actual yield is whatever the problem tells you you made in your lab. So your actual yield will be 40 grams in this case of CO2. So jot that down on your paper. Okay, so when you guys do your assignment problems, there's going to be a part B where it's going to tell you what your actual yield is. So the number they give you in part B, that's your AY. All right, and the last thing that you're going to find today, and when we do our lab, you're going to find this as well, is something called the percent yield. And there's a formula for this. The percent yield is pretty simple. It's going to be your actual yield divided by your theoretical yield, and then you're just going to multiply that by 100%. Okay. And this is pretty much like a grade that you can give yourself for your chemical reaction. So when you guys do your experiments in the lab and you create a certain amount, you make your actual yield, you can divide it by your theoretical yield, and that gives you the percentage that you made. Okay, so you can kind of think of it as your grade. So how much you made compared to the theoretical possible amount. Okay, but if you get like a 40% yield, I'm not going to give you a 40% in the lab. So don't think of it that way. It's just a way that you can think of how efficiently did this reaction run? How close to the maximum did I get? Okay. All right, so let's plug in our numbers. Our actual yield, according to this problem, is 40 grams. So we're going to put 40 grams on the top of the fraction. We are going to divide by our theoretical yield, which we found to be 41.13 grams. And then we're going to multiply that by 100%. So the way that you're going to plug this into your calculator is the same type of math. All the numbers on the top you multiply, numbers on the bottom you divide. So we're going to do 40 on the top divided by 41.13, and then we're going to multiply that by 100. And that's going to give you your final answer. Okay, so take a second, punch that into your calculator, figure out what the percent yield is. This is pretty much the only thing we're adding on. We'll go over the percent yield, and then I'll get you guys started on your side. Alrighty, guys. So you guys should have gotten percent yield of 97.25%. Okay, that's it. That's the only thing that we're adding on. Now, again, this does get a little bit more complicated when we do the actual lab because I'm not going to give you guys the actual yield. I'm not going to tell you, hey, you made a certain amount. You're going to do the experiment. You're going to weigh the chemical you made, and that's going to be your actual yield. Keep that in mind. Okay, today I'm going to tell you what the actual yield is, but when we do our lab next class, you are going to actually be weighing it out. Okay, that's it.